Okay, so we're going to look at stationary points now. And as you can see from the definition here, stationary points, you know what the word stationary means, not moving. If you're stationary, you're not moving. Stationary points are the points on a curve where the curve is not increasing and not decreasing. So we've talked about, here's a curve, and we've looked at what's happening to the curve, and this brings into our discussion rates of change, and as you know, that's what we've been looking at for a while now. So this part of the curve here is increasing. You see from we're working from left to right, and in that case we're going uphill, aren't we? We're increasing. It's increasing as x increases, so does y. So this is increasing here. And you can tell you hit the top of the mountain and down the other side you go. Now we're decreasing, and then we hit the bottom of the mountain and back up we go. So we're increasing again, and so on. So that's how the thing works. But what about at those points, those exact points here, where it's not increasing anymore, it's not decreasing, it's right at the top. So those points there are the ones known as stationary points here, these ones here. Now, what do we know about those points? Well, we know that if we draw a tangent there, then we get a horizontal line, so a gradient of 0 at that point. So alright, so the gradient of tangent equals 0 at those points. So these are our stationary points here. That's our stationary point. Now, a stationary point is not specifying whether it's a maximum stationary point or a minimum. We'll get around to that another time, but it just refers to where a point is stationary in terms of its rate of change. So at that stationary point, if we're thinking here, well, our derivative, if this is f of x, then what we've got here in this part of the curve, we've got f dash x being greater than 0, and in this part here we've got f dash x being less than 0, but at the stationary point f dash x is equal to 0, and that's how we find where our stationary point is. We find the derivative function, we get the gradient function, and we make it equal to 0, and we find out what x is at that point. So take this note down, also take this neat little diagram down, and then you'll be right to go. I'm going to get a couple of examples going, so I'll just pause while we write that out. Okay, so we've got a couple of examples here. They're from the textbook, page 585. So in this first example, what we're asked to do here is find the stationary points of the following functions. So here we've got a quadratic. It's a negative quadratic, so it'll be one of these guys. And here we've got a cubic, negative cubic. It's going to be doing something like this. But what we want, I'll just have a like this. This will be something like this. Doesn't really matter, just so that you've got an idea. And a cubic will be something like this. So what we're expecting here in this question here is to find a stationary point up here somewhere. And in this question we could find two stationary points. So let's go and find out now what's going on with this. So when it's in y, I can write y dash or dy dx, but we want the derivative function here, the gradient function. That's 12 minus 4x. So that's the gradient function. Now what we want to do is find out when that equals 0. When does that equal to 0? So what we'll do when we solve this, we'll have the value of x here for which the curve is stationary, or the function is stationary at that point. X equals 3. So find the stationary points. So what we've got to do is find the y coordinate there. So x equals 3, that goes back into the y equation. So y is equal to 9 plus 12 3s are 36 minus twice 9 is 18. So we get, it's 45 minus 18, which is 27. So the stationary point is at 327. So therefore, stationary point at 327. Okay, so what I want you to do now is pause this video, have a go at B yourself, and then restart it. Okay, so you've had a go at B, hopefully. Let's now check it out. If you haven't had a go at B, come on, just pause the video and have a crack at it. I don't care if it's on a spare bit of paper or whatever, it doesn't matter. But let's just have a go. Dy dx Gradient function again, 3 minus 3x squared. Okay, that's going to be equal to 0 for the stationary point. All right, that's what we do. We get the derivative equal to 0 for the stationary point. Go back up here. What's happening at the stationary point? The derivative function equals 0. That's what's going on. So let's solve this then. Therefore, look at this, 3x squared. I can see what's going on with this one. Divide through by 3, x squared equals 1. So x is equal to plus or minus 1. Right, so what we need to do now is when x equals 1, we want y. We know what y is. Go back up to the original equation. 4 plus 3 is 7, minus 1 is 6. So y equals 1, x equals 1, y is 6. When x is minus 1, 4 minus 3, which is 1, minus 1, plus 1, so that's 2. So y equals 2. So we have the stationary points at 1, 6, and minus 1, 2. So we just write that out. Therefore, stationary points at 1, 6 and what do we say? Minus 1, 2. And we're done for that question. Okay, so our second example and last example is just a different type of question. Let's have a read through this. The curve with equation y equals x cubed plus ax squared plus bx plus c. Right, so they're not giving us the full equation here. We're going to have to find some stuff out. Passes through 0, 5. So it gives us a point that it passes through. That's going to be useful. With a stationary point at 2, 7. They're giving us the stationary point. Right, so this is around the other way, isn't it? Now, here's your stationary point. Find out what the equation is. Find ABC. Okay, so the first thing we can do, it passes through 0, 5. Right, so let's firstly put 0, 5 into the equation. So 0, 5, we get 5 equals 0 plus 0. We're putting 0 in here for x, aren't we? 0 goes in there, so there's lots of zeros plus c. So we've got c equal to 5. That was easy. So now our equation reads x cubed plus ax squared plus bx plus 5. Good, so we've got c. Now what are we going to do? There's a stationary point at 2, 7. So I also know that 2, 7 lies on this, is a point on this curve. So I know that 2, 7 satisfies this equation. So I can do the same here. I won't get quite as much info out of it. So 7 equals, now 2 goes in for x, so that's 8. 2 cubed is 8, plus 2 goes in for x here, so that's 2 squared is 4a, plus 2 goes in for x there, so that's 2b, and c we already know to be 5. So therefore, let's tidy this up a bit, 4a plus 2b will equal 13 here. 13 goes over the other side, minus 13. 7 minus 13 is minus 6. Can do better. 2a plus b equals minus 3. Right, that's equation 1. Now, what else can I use? It also says it's a stationary point there. So let's go, so we've got an SP at 2, 7. So how can we use that? Let's get our dy dx. So y dash is equal to 3x squared plus 2ax. Right, 2 comes down. Excuse me. And 2ax plus b, and then the c we forget. Right, so there's a stationary point at 2, 7. So I've now put in, this is now my gradient function. They're telling me, isn't it, that this is equal to 0. This is equal to 0 when x equals 2. Right, so we sub 2 in here, and we're going to get 0. That's what it's telling us, a stationary point x equals 2. So therefore, let's just do some work on this. When x is 2, 2 squared is 4, so that's 12, plus, when x is 2, 2 times 2 is 4, 12 plus 4a plus b must equal 0. 12 plus 4a plus b must equal 0. Let's write that in the format here like this one. So that says 2a plus b equals minus 3. So I'm going to say that's 4a plus b will equal minus 12, and that's my equation 2. Now let's put 1 and 2 together and solve simultaneously. I think what we might be able to do is take 2 and subtract 1. So I'm going to take equation 2, subtract equation 1. The reason I'm doing that is I can see I've got a b here and a b here, so if I subtract, my b's are going to go. 4a minus 2a is 2a. B minus b, gone. Minus 12 minus 3 equals minus 9 minus 12 plus 3. So a is equal to minus 9 over 2. Okay, so if a is minus 9 over 2, then what's b equal to? I can go into any of my equations. I'll go into this one here, I think, to find out what b is. Therefore, twice that, minus 18 over 2, plus b is equal to minus 3. So therefore, b is equal to minus 3, and this is 9, isn't it? 18 over 2, plus 9, so b is equal to 6. So therefore, a is equal to minus 9 over 2, b is equal to 6, and c, right at the start, was equal to 5. Okay, so you can see the gathering of evidence, lots in this question, lots going on. They gave us lots of information. We use it all, we set up some equations, and we solve. So you might find that in 20C, you need to use those sorts of skills. So in 20C, I will pause and have a look at the work requirements for that, but we will have a look at that in class. Okay, here are the questions from 20C that I'd like you to do. So disregard what's written on your sheet with the work requirements and get these questions here done, please. But that's the task for your next lesson. Okay, see you then.